Hello everyone, welcome to the stream. It's not Dutch weeks. I don't know. I didn't receive Jordi's care package. Boo, Jordi. Didn't you want to send me some Zuckerhagel? What's the name? You will send it tomorrow. Okay. Yeah, next week then. I will do Dutch week next week. Lutefisk ice cream. What is Lutefisk ice cream? Busy at work and had 3 Freiburg. Oh yeah, that explains why you haven't been to the live stream. I was worried about you already. So today I have only a Kinderriegel. Hey Sonic, thank you for the sub. Yeah. So, who is feeling as tired as I am? I watched, I don't know, season 4 of Stargate SG-1 in 3 days or 4 days. I'm totally exhausted. The pattern repeats a little bit right now. They're going to a world. Either they are hunted by, in the beginning of the episode, hunted by the Jafar, or they get like they are hunted by a ghost, and nobody believes the person that sees a ghost, and that's the pattern. Hey, Kitarp. Oh yeah, you have to greet all the people. I was on Sion's stream yesterday, Unexpected Maker. It was also fun. It was a lot about politics. No. Hey Rohan, hey the Shipu, hey Ray. Hey Christian, you're on YouTube. What happens? Resub. The TTS is crazy. Hey Johnny. And oh, we have a hype train. I don't have a special sound for hype train yet. Hey Cool Pet. Hey Ricky. Hey Kitarp. Hey Streaming Elements. And Christian on Twitch. A HD version of Mortal Kombat 2 came out this year 3D. Oh, it's badass if you all like Mortal Kombat 2. Yeah, I never had like that was Sega, wasn't that? Or Mortal Kombat was I was the Nintendo world, if any. Yeah, the only food I have today is the Kinderriegel. Don't buy it. They are ripping off. They are fucking expensive and demonetized. It's like, what do you pay for a packet of Kinderriegel now? 5 euros? That's like 10 Deutsche Mark. This is crazy. Madness. I just got this from my spouse. Sorry for letting me stop. No, I had some sałatka today still and some Polish sausage. We have still some meat. Favorite foods where I live? I love döner. Let's say döner is my favorite food from where I live. A pack of 24 small bars is 4.69. And it basically is made from dry milk, sugar, fat, and a little bit of cocoa powder or whatever, or cocoa butter. Like It's mainly like cheap ingredients like sugar and fat. Let me check. Oh no, it's 40% chocolate, but it consists mainly the chocolate. Main component of the chocolate is sugar, Zucker. Then we have Vollmilchpulver, Kakaobutter, Kakaomasse, Emulgator, blah blah blah. So 50% of the 40% chocolate is yeah, yeah, it's odd number. 21 grams. That looks kinda sus. What? Johnny, thanks for the sub. We are almost hype trained level 2. We have 93%. Yeah, that looks always a little bit sus. Okay, then interesting. So we have like main component is sugar in the chocolate. Then the next ingredient past the chocolate is it's so hard to show on this camera. I need to set up the right camera. And we'll talk about talk about how healthy this food is that I'm consuming here on stream. So get me closer and hands. On-screen chat doesn't work. Wait. Let me fix that. Here we go. On-screen chat fixed. Yeah. 10 minutes late, yeah. Oh, sorry. Nobody was that's rewatching the stream knows what I'm talking about. Okay, so we have at least 20% sugar here. That is 40%. The next ingredient, okay, we can't tell how much that is. I would need like the big packet to tell how much sugar in total. But Magermilchpulver is 18%. So sugar is at least another 19 or 18 or 19%. So we have at least 40% sugar, almost like 39, 38, at least 38% is bare sugar in this. And then you have like, okay, Butterreinfett, that's at least quality fat, like from butter. Soya, vanillin, blah, blah, blah. Here you go. This is resub. Hey Johnny, thanks for the resub. Yeah, that's the issue. You don't buy the big packets. You will eat them all. You will just pay more. Anyways, rant over. Shrinkflation rant over. Eat an apple a day to scare the doctor away. But this one doesn't look as good anymore. It's sitting here since the first food stream that we did a few weeks ago. I didn't eat it since the Polish stream. Okay, so here comes the proof that I'm Polish. My father is going to collect mushrooms in the woods tomorrow, and I asked him if I can come with him. I can't distinguish them very well, but yeah, I'm looking forward to spend a nice day tomorrow with my dad in the forest collecting mushrooms, and people like Polish people love that, collecting mushrooms. I asked my neighbors here around where are the spots where you can find good mushrooms, and they didn't know. Nobody collects mushrooms here anymore. YouTube chat disconnected. Pierogi restaurant? What, Sonic? Ah, that's cool. I'm envious. Wait, Johnny has 6 stars. What's going on? Is this auto incrementing? All right. So let's talk about. I sorted my tabs. I will prove it to you because I cleaned up my table a little bit at least. And this with table I mean my desktop. Look at this. You can do tab groups. Okay, these are like open tab groups. Oh yeah, I have to still watch this one. When I watch later. Save. Save to watch later. Here we go. Okay. Anyways, that's unsorted. Case place numbering like some stupid stuff. Yeah, I wanted to check on JLC. What is this data sheet? Okay, it's so hard with the RP2350. It's really hard to design stuff. Okay, that was recommended to me yesterday. Investment. I want to invest in stock markets. Here, C64 cluster 3. This is the project that we will work on today. And let's take a look here. People said that my last cluster this year, it totally looks like the MPU T800 CPU from Terminator. And I thought, oh well, let's make one for the people as a USB stick, somewhat like, I mean, this form factor or something. And we make it like a basic USB-C board of somewhat that size or something. I don't know, like the shape or whatever. Basically a proto board. And I thought, okay, I want easy accessible programming over USB. The only MCUs that can be easily programmed over the USB are ESPs with MicroPython or something on them, and as like ARM Cortex, which can boot into also as a file storage device. And I thought, okay, let's do the following. Let's take the Raspberry, since I don't want to design really complicated boards. I thought first, let's take the RP2354, which has integrated over the USB. If you flash that bootloader on them, yeah, you can flash it over USB using this extra tool, but you don't have the tool. You always need like extra software to program it. If you have like a thumb drive that provides everything, you can just open Notepad and start programming or whatever. And if you have like only like CDC or something, because I think a mass storage device needs full speed USB, CircuitPython. Yeah, so I thought, okay, I will try doing the RP2350 because it has FPUs, it had some power. So and if we look at this device here, we see it has 15 boxes. It's more like shaped like a box. It's still smaller than probably this MCU. So this MCU is bigger. If you look at that, it's like the size is too big of the 80 pin device, but I will try using that anyways. So I checked, I started designing the board, and let me show you, where is it? Is it this one? Yeah. Ah, okay. One problem is it has an internal voltage regulator for 1.1 volts, and this is a pain in the ass. You need like a specific polarized inductor placed properly so it will work. Let me show you here. They have like recommendations that this is the inductor, this is the circuit, and you need to place it like that, and it's a specific inductor, and the inductor costs like 20 cents, which is like quarter of the cost of everything. So if you check here, this part on LCSC, this is not that, this is Texas Instruments. What is this? It's the 1.1 volts. Yeah, this, I need this LDO, but let me Skynet by bitluni. Yeah. Did my chat disconnect? What happened? I can't hear. What happened? It's broken again. Anyways, yeah, if you look at that, okay, 12 cents, but in bulk, like 6,000 pieces. But if you buy like 50, it's 20 cents. Come on. The RP 2354 orientation markings, yeah. Here, okay, it's like, it's not a quarter, but let's say stacking at 170. So you have like 20% almost more cost just for that inductor. Isn't a module then better? Yeah, but I can't put like the module in like that on the board. And this is what so I said, okay, screw that, I won't do it. I just put plenty of LDOs, 3.3 and 1.1 volts. So this is 3.3, this is 1.1 volts. Like four pieces in parallel, that would be plenty enough for my test so far. This is the test. I have this is the RP. It has nothing. It has nothing. It has test points. That's all right. I'm connecting the boot selection to one button, as well as the run, the reset, or whatever you like, also to one button externally. And then we have 40 Pimoroni Explorer. Yeah, this one is also Pimoroni thing, but it doesn't has the USB. We will test that thing quite soon, because I wanted to try that with the C64. We wanted it's supposed to be 5 volt tolerant, but then it isn't. If there is no power, if you have like 5 volts on the GPIOs and the VCC isn't stable yet, then it will probably break. If you find an amp in an alley, then something's really right. So here, oh yeah, I got it from Botland. It's strange. The parts are not very available, but also I wasn't able to find like from the RP2350. There are no like KiCad designs online by Raspberry. They have like all open source designs for the RP2040, like the basic, the minimal design and everything, but not for the 23. I had like to replicate, make my own whatever footprint, and so probably there will be bugs in this one as well. But oh well, it's a quite expensive experiment if I really want to put like 15 on one board. Ah yeah, here's the interesting part. I found. Let me check that. Is this? No, this is WCH. This is the RP. This is the stupid thing. I wanted to show you the USB part that I picked. I might have closed the window already. Yeah, test. Oh yeah, here. USB hub. It's so simple. It has, look at that thing. It has everything inside. It has like own VDD, like 3 volts, 3.3 volts and 1.8 volts regulator internally. You just connect that, add 2 caps and 1 crystal, and then you have a 4-port USB hub. That's so cool, so easy to use. This is how the MCUs should also look like. It's getting just more complicated and more complicated. I don't know, they should like, compared like to RP2040, the RP2350 should be simpler to implement. Like they already put the flash with the 54, stacked it. What you've HDR? Oh, okay. License. Let me check. Pub GPL. Yeah. All right. Yeah. Anyways, I have like the design replicated the design, also the reference design, and now I'm simplifying it. I would love actually not to burn. I'm burning a lot of power, like 2/3 of the power is just converted to heat. If you consider that we're LDOing from 3.3 volts to 1.1 core voltage, that's a lot of waste. Maybe we should design like a good 1.1 volts regulation instead of this thing. But maybe we just start like with 4. A buck regulator. Yeah, that's what I mean. One buck. Do you have a recommendation for a chip? Why is YouTube chat not? Does this have to do with this one here? Oh, okay, that was my fault. YouTube chat should work again. TTS. What? Oh no! Oh, it's reading back all the chat from the beginning. Oh no, I'm listening to the chat. You know what? I will remove my headphone so I won't be stuck for half an hour for this chat to reappear. Rabarba. Okay, so yeah, should we design a power supply? Clear Q. Power supply, or continue making the board? We can make the board like, okay, I have no clue. This is centered. We can make like a 4 MCU. The funny thing is, when I press like to enter the bootloader, it will like four thumb drives will appear on a PC. Oh shit, okay, yeah, I have to change the grid. Huh? Why is this? It looks like it's not centered, huh? Okay, here. So, yeah. Now people talking about season 4. That's the crystals. So, another problem that I found with the RP2350 is, the chat is still reading. You can use instead of like 4 crystal, we can use like 1. Reconnect to the chat. Yeah. Oh, you're right. I could reconnect to the chat. That's easy. Here. Oh yeah, that was easy. But it's not ensured that like the USB will work properly if the configuration of the oscillator isn't correct. So I have no clue how that works. I will put just 4 crystals on the bottom of that. So let's flip those here. Flip, flippity flip, flip. This one goes here. Possibly, I don't know, maybe we put it on the back as well. And these are the regulators. Buy some XP. Thank you very much, Johnny. Okay, test point. Yeah, I will put them on the bottom, the caps and the resistors. I will put everything on the bottom. I hope that will work with the... Let's see if I can make them that dance. It's a the only problem that I see is we have like 48 bus lines that we need to interconnect with all the all the MCUs. There's no way of doing that. We can't put as many wires next to each other. (18-layer PCB, yeah, with buried vias. Okay, I admit, maybe we need like a switch mode power supply. FPGA time. Okay, peeps. Let's do power design. The LDOs is a nice idea, but I don't think that we can manage to do that like that. caps. Okay, what is the track width that we can use there? 1.5 100 no 150 microns. Vias is what size vias did we have? Like 0.5, and the hole was 0.3. CH32 chips with programmer running on the upbeat. Yeah, but I have no clue how the programmer works. RP2040. Yeah, that would be an option. I don't even need the hub. You're right. Oh, for the WCH. Oh. Yeah, another option would be the CH303. But isn't that funny if you press a button and 15 thumb drives appear in on your PC? That would be funny. Come on. Or we do something else. We use this to yeah. Uh, Disciple, do you have a link for that programmer? I'm so sad to dismiss this design. We have like 48 lines. Okay, I also need to check what is the design rules. Track. Foo! Thank you for the donation. Yeah, I mean it's I didn't know that there is something like that. If there is like a dual power supply datasheet voltage regulators, let me check that. XOLDR megahertz buck 3 amps adjustable. 3 amps sounds good. That's like USB. But 3 amp input or output? That's really tiny. I like that. Almost, foo. I didn't. I forgot. What was that about? That was JC stuff, wasn't it? Ah, continuous output current. That's still low for like 15 MCUs that can draw like I don't know 200 milliamps. Ooh. Oh, that's perfect. Phew, that's perfect. I have to try. I just forget because. What is this? Okay, here we go. Oh, that's cool. You are a master hacker, Fu. Hey, Keskila. Oh, too many pins. What do I have? Ah. Is this like... Enable needs to be like lower voltage? 5 volts. Yeah, you see, it's getting more and more complicated. Okay, that's feedback. Do not place. 22, wow. That's big caps here. And that's the ratio, or is this the ratio? Where is, how is it connect? 41. Oh wow, that's quite some thermal vias here. And that's the inductor. Resistor, cap, 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 cap. Okay. Are there any pre-calculated values for certain voltages? Or do I need like to calculate it here? IO max. here. RVS RSWDIO. Huh? 32. V out, yeah. Okay. But there is nothing for 1.1 volt. Ah, this is so getting complicated again. But I didn't order, you know what? I will do this. Aha! PP. USB PP. What's PPS? Oh, you mean like power? What is it? Oh yeah. Yeah, I know this is the bootloader for. What did I want to to check? No. Oh, we get some some coupons here. Okay, I ordered. I showed you last time already. I ordered some books with 0603 and 0402 resistors and capacitors, but the inductors were expensive. We can buy them today. Where is that? Doxing myself. No. Ah. Is this Labubu? Here. Boop. Boop. Are those ceramic inductors? We love the Labubus. Ceramic inductors. 0402. 1.1 volt. It's supposed to be 1.1 volts. We can check it. .75 and 10k ohms. Here. This is what Google says. What? Okay. But what is the inductor? Let's check for voltage settings, inductor selection. Oh, we are free to use any. Saturation current rating, okay. DC resistance, beta efficiency, okay. I take that. I take that, Google. So let's design this stupid part. Let's go back to this one here. If I can make the design here, what's the part number again? TPS 62. TPS 62. 933. Salt 3 amps with forced continuous conduction mode. What is forced continuous conduction mode? Does anyone know? And mode and power goods. Pulse frequency modulation and wow, whatever. We take this one here. Yoo-hoo! That is easy. We need two, don't we? We need one for 3.3 volts and one for... I don't know what that means. Okay. Wait, is this the basic schematic on the first? Is this, yeah, wait. 5 caps. Lückender und nicht lückender. What does that mean? Okay, we have, what kind of caps do we have here? We probably don't have... No, there is the output and input caps. Oh, you mean we can probably... Feedback soft. Nah, I don't want low efficiency drawbacks. Wait, this is... Let me take... Shit, what is RF? Okay, let me take 10K, we had 10K and 3.5K. 3.5, was it 3.5? Wait. Uh, 375, okay. 375K. Yeah. Ah! Okay. Where's the... Now too many things open. Now I need to find the detailed schematic. Ah, shit. Where was the calculation again? Ooh! Where was the table for the... output capacitor selection? There's so much stuff to... Top, down, okay. Top. Wait a second. This is in kilo ohms. 33, 31, 33 and 10. Top, down. And now I need to find this stupid because it's not on the same page. And what is the top and what is the down? Ah. What a terrible data sheet. It's using everywhere different labels. Here there is no top down, it's FBT, FBP. I will certainly put a 0 ohm resistor before powering, or something that I can measure without plugging in. What is this, by the way? This is like 100K, 10K, 5 volts output. What is expensive? how is that selected, the frequency? Microfarads, micro 30, typical effective C out. Wow, that's a lot of capacitance. Minimum is 10 microfarads, okay. Inductor 2.2, or is our top? This is the only spot where it's mentioned. Ah, here. Here is. Okay, that's the voltage. It used to blah blah blah. Bottom side, this is bottom side, and top side is that one. That's V out, and this is. Oh, okay, now we got it. Oh! Annoying, annoying. Okay, let me get to the first page. This is bottom, top. That's out. Feedback. That's bottom. Ah! That's annoying. Bloop. Now we need to check. We need 10 times 2. Or even 3 will be alright for me. We will copy it anyways. Let's design this one first. V in. $20. Enable. Floating pin of what? BST or SS? No, SS is. Huh? Wait, ground is a cap? What? No, ground is here. What is SS? Tie ground to. Okay, that's it. Ground. Then we have. Here it says not SS, like Staatssicherheit. It's here, it's SW. Who the fuck copied this? Is this made with ChatGPT? Switching output converter internally connected, high side fat and drain low side fat connect to the power inductor. What? Let me check. Soft start control pin. What does that mean? Ah, here we go. 33 nanofarads, okay. Why do they make it so difficult to find that stuff? Okay. Okay. This is powering a lot. I need to figure out the, okay, now the selection of the top bottom. This is so annoying. Oh yeah, there is the inductor missing, and this is this whole thing is missing here still. Yeah, the core voltage and everything else. Okay, we have top is 31.3. So, come on. X, no. I wanted to copy it. What was 33? A vagiminator. By Picos, yeah. I have no clue. This apple rots and it stinks. I will just throw it out of the window. So it doesn't stink anymore. I will get some mute. Peeps. With this nasty glass that I used last week. It's still here, but I mean, this is bad apple in real life. Cheers. I should have made battery out of 2 apples. I have plenty apples. I have still several buckets of apples left. Okay, inductor. Why was there like, oh, they tested the resistor C out. That's the C out. RT was the selection. Enable is 5 volts. Let's do it here. Enable. Oh no, enable precision trace. I just want to know what's the maximum voltage. If it's 5 volt tolerant, then we can just use enable. Five, okay, that's all right. We can do it like that. So that's quite simple. Now we only need the inductor still. Wait, is the divider is after the inductor, yeah, here. We need to pull it apart a little bit. So spoil me. When does Apophis die? I watched this one Stargate movie. I don't know in which season that is connected to. Where they basically there was like an execution of Apophis. And then he made copies of himself, and they were traveling back in time, or it was too long ago. Wait, what is this cap? Is this even like 1 microfarad? I don't believe this. Oh, come on. Give me that. L1 and time paradox. Yeah, something like that. I don't know. Can't remember properly. Stargate for the win. Yeah. Yeah, but the dude is annoying. I mean, usually the Gua'uld will keep him like young and fresh, and through the 4 seasons, the young guy that plays Apophis is aging, and you can clearly see it. I mean, he was like almost dead a few times, but yeah, we need something. Spoiler alert, end of season 4, they killed off Kronos like in a very quick and simple. That took like a few seconds or few minutes to kill Kronos, and I felt like Kronos was more significant than Apophis before. Somehow it was a little bit disappointing. I hoped for Kronos to be a greater villain than this funny dude. Anyways, as you can see, I'm clearly into that right now. Okay, 100 nanofarads. Let's fix that. 100 N. Copy paste, and we had the value for inductor was 2.2 microhenry. And this will be bloop, bloop, dip, dip, dip. That looks all right. That looks decent. We need to find the right inductor with yeah, but we need 3.3 volts and 1.1. So I start with 3.3 volts because we need some current on 3.3 volts as well. And I don't want to waste that with LDOs. Please don't go. Don't go away. How do I deactivate this one? Do not populate? No. How do I want to keep that because I'm proud of Don't want to destroy this yet. This contraption here. Right mouse button and then do not populate. attributes, exclude form from board, do not populate. You okay, here we go. Nice, thank you. Ah! Yeah, let's move this to the side and then. Okay, now let's do 1.1 volts. Ok. And take the values of 10k and that doesn't sound correct. What was it? 3 point, wait. 3.75k. That doesn't sound right. Does it sound right? Okay, so Google says oh, the reference voltage is 0.8. Okay, is this the internal reference? Now we can see 3.3 is 3 to 1. 14, so it will be no, that is not correct. It should be almost like three. If 5 volts is 3 to 1, wait, let me calculate it. So Google says reference voltage. Huh? Did it need to check that with the data sheet. Oh, look at the efficiency. 5 volts. You can't see the color. What? 3.3 volt is not effective. Oh, 80%. Okay, it's some. Oh, switching frequency 500 kilohertz. Wait. Here we go. This is what we want. Okay, so this is 10k. Okay, let's calculate it. Then times out is 1.1 minus 0.8 divided 0.3 divided by, oh no, it's correct. But they are reversed. 0.8 equals, yeah, times, I reversed the, yeah, if we do that, that's correct, but it's reversed, and the naming was not clear. So this one goes, which one is R? Here. Should we test the output? But we don't know the output if there is no load. Should we put like a 0? Wonky again? It's lagging. Let me check what's happening there. Here. Let me see if we can redeploy it. I fixed something that I should have fixed long time ago. Here. Okay. Let's see if we get an update. Nope. So sorry. Connecting to chat. Welcome to the chat room. Did I just lose my connection, or what's happening here? This is odd. We need some more mute. Okay. We don't need this. Should we put a 0 ohms resistor here to test it, or what do we do, peeps? Also, what kind of do we need like a different inductor for that? I use 6.8 for 2 points. Hey Hex. Okay, 3.3 volts is 2.2, 5 volts is 3.3, I guess that will mean. Oh God. How do I calculate that? Is there a formula for the inductor? Yeah, thank you for watching. Yeah, I don't mind typos. Inductor, let's see if there's an inductor calculation formula somewhere. IO max. They use for the inductor for the current peak to peak, half of peak to peak, blah blah blah. I will just use the same. Ah, wait. Here. What the f... Okay, let's see. Let's calculate it. 5 minus 1.1 3 point divided by what is frequency, switching frequency, 1.2 megas times what is K, times 3 for output times K. What is K? Fast, fast. Okay, times out 1.1 divided by 5 times. What is K is the ripple ratio? Oh yeah. Delta divided by oh no, IL Wait a second, why is this so big? This should be like really small. This didn't work. Oh, I didn't 3.9 divided by 100 millions equals and then divided by again. Okay. Huh? It's not a reset. 3.9. I hate this calculator. This is what I'm looking for. Times 3 times 1.1 divided by 5 divided, but okay, we can see this is like 2 microhenries or something if we keep like K at 1. I don't know what 2 micro. I don't think we need to care about it so much. This is Okay, they have 1 microhenry at 5 volts, so it is like oversized for. It should be smaller than 2 point. Wait, was it 2.2? Why did I have 1.1? That was wrong. We need 2.2 here. That was a typo. Yeah, we have so much problems adding the voice to YouTube because somehow the scraping doesn't work properly. It fails all the time. Usually it would also show YouTube chat combined with Twitch, so that's why it's look at this. Look at this mess. This is how we process with Node-RED the chats, Twitch and YouTube combine it, send it to servers and whatnot. Hey, Voodoo Weasel. Yes, 2.2 microhenry, but how do you calculate for 1.1? Is it like too high? It should be proportional. It's not like quadratic or anything. So if we have 5 volts is 3.3, 3 volts is 2.2. This is probably somewhat proportional, isn't it? What do you need to screenshot? Yeah, take it here. Wait. It reloads just by moving the page. There is also it has like an NoSQL database because you can basically on screen. Yeah, I know. That's why it's probably not working properly. Oh wait! I have an idea. I restarted. Maybe let's reconnect. Chat. Properties. It's only dead for. Yeah, no. I have no clue what happened. Okay. Yeah, I'm so sorry. TTS sucks as usual. I don't care. Okay. So, what do we see here? Is there like what typical inductor would we use here? Switching frequency is like proportional. Oh, you're using a language model. Okay. We're using just Google's Chrome, TTS stuff. Okay, let me check for, there are specs for the inductors here. What happens if my inductor is too big? Number follow. Next programming. Hello. Or are those people who are just switching from YouTube because the chat doesn't work? Custom design using the bench power designer. Oh, look at that. 5, 5. Output 1.1. 3. Oh yeah, we need a part number. Maybe it was easier than expected because the data sheets are not very clear. Where's... Huh? Why did I put... Thank you. We are designing another cluster, but it has high demands on power, and USB can only provide so much power, and the RP2350s they require a lot of current, especially 1.5 volts. So wait. Power designer. Oh, wait. Is it 3? Oh, look at that. 3F, 330. Are they all the same? It uses also an extra 100 micro. 374 output. 1.8 microhenry. Here we go. That was easy. 1.8. Okay. Other than that, that looks almost correct. 1.8. And I don't know why they chose 7.4 instead of 7.5, but I take it. Yeah, 2 voltage levels and it was 70 milli ohm, 100 and I'm missing still 100 N here. That's 47 microfarads. Yeah, they're overdoing it. Maybe I will add the extra cap in front of here, the 100 N. Yeah, here we go. So we have both now. The power supplies, amazing. Is it connected to a footprint? Yes, it is. Nice. Then we need pi pico. Now the new one needs 2 voltages, but has like a super complicated setup for a polarized inductor, which costs too much. So I will just power, since I want to power multiple ones, I would have like to put like for each of the MCUs one expensive inductor. So I rather use one power supply that powers all of them at once. So we have the power once, and then internally there is nothing connected to the regulator here. Nice. Here we go. Okay, let's go for cheap. All right. I want to find a nice inductor here. So let's find inductors. Oh fuck, sorry. Passives, inductors, fixed inductors, here we go. You remember when we did one, fool. Let me switch to the category so we can filter properly. Okay, we wanted 1.8, was it 1.8? One blade is processors. What do you mean? If you watch the video, with the supercluster, then where's my tab? I'm already lost. Here. Many comments mentioned that it looks like, here it is, by the way, that the blade looks like the Terminator T800 CPU, and I just want to make one that exactly looks like that, but you can connect it to USB and maybe put it to mass production in China, so you can just order it from Ali at some point. Why not? I'm not sure if I will use the RP socket block here. A little bit like, it looks a little bit like plastic, painted plastic. All right, yeah. Was it 1.8? Oh, what is this? Don't need that anymore. Let's close it. We need 1.8 and 2.2. Okay, 1.8 microhenry. And we need current saturation should be, current saturation was half, or at least 3 amps. Let's see. Murata. Oh wow, yeah, hefty. SMD. Oh shit, no, that's like the boxed ones. These are huge huge inductors. No. Saturation. Okay, let's go to the saturation. The most critical for the inductor are the inductance, saturation, RMS current. The inductance based of the yeah, but it's cheaper if you buy it like from stock than producing it. So the error rate of the inductor is at least as large as the high side switch current limit. What is the high side switch current limit? That's our output? No. Does not saturate even during short circuit on the output. When the inductor core material saturates, the inductance falls to a very low value, causing the inductor current to rise very rapidly, although... Oh shit. Either we need like... What is this? RS current 3 amps. Word electronic, okay. Yeah. Oh no. Did I close my... Okay, so you know what? Let's assume, I should. Where's my LCSC? 3 amps. Okay, you know what? We do minimum 3 amps. Okay. And then we need also in stock and apply to all and shoot. Clear. And then current rate maximum. It's minimum 3. Okay. All right. Here. What? Current rating 15 milliamps. 7, yeah, too big. I don't want this big. I mean, I could use it. What is this? Interesting. Oh, this is more what I'm looking for. But this is 50 milliamps rating. Why is it at saturation current? Fool. It scales too much. You won't see anything. Okay, current rating. Let's do current rating min 2 amps. I don't know what the difference between saturation and current rating, because for me it sounds like it's very same thing. Doesn't update. Oh yeah, okay. Huh? Huh? It ignores it. Okay. Yeah, we are stuck with only the chunkers here. What is this? Asian brand, 3000 in stock. That looks nice. I don't know if I trust it, but that's for sure. 4 amps fixed. Okay, let me check it. That will blow up. Wait, if the resistance is that's too. No, that's microhenries. 0.8, 1.8, 50. What is this? Typical milliohms. Oh, that's all right. You know what? Let's go for it. Just copy that part, and package is this one here. Okay. Maybe we should we should add a 0 ohms. No, you can't. They are using one for 20 cents. Like, how much is it anyways? Oh, that's expensive. 35 cents. But it handles more current. Damn it. That's a chunker. Oh, that's hefty. Let me check other ones, but I like that one. I must admit. Okay, what if we use? I mean, we can put anything on the bottom, like this chunker here. Wait, let's sort. $0.03. Look at that. 4 amps, huh? Huh? Isn't that the same? Oh no, that's external price. Yeah, okay. Sorry, that's external price for whatever. This was 3 cents. Okay. That was the same one, yeah. I think this was the same one. Yeah. Okay, I guess. Inductor, we just add LCSC number this. Then let's add the data sheet. Maybe I add the web page. That might come handy. Then footprint is doctors L. Footprint 8. Okay. Metric. That looks okay. About 224. Okay, yeah, you mean that okay. What we do is we don't trust it, so we put in a fuse here, which is 0 ohm resistor. So when we receive the board, we can just desolder that, test the output, and see if it behaves, and then connect it. I rather trust this one, but we can add this as well. I mean, for the first time we can remove it. If it works, we can always remove it for the next revision. But this is something that before powering up, I can test that before I melt like 15 MCUs at once. Also, let me check something. If I have 10 microfarads here. No, I don't have 10 microfarads. What I'm wondering is why is there a 4.7 micros at 1.1 output? That's a little bit interesting. Hey, Brian is here! I missed. Oh no, I'm missing all the chat in YouTube. Oh, the pipes. Oh no. Brian, did you watch the F1 movie with Brad Pitt? I liked it. I liked it. It was entertaining. It has a little bit of a Hollywood vibe at the end, which is, yeah, but other than that, I really enjoyed it. I know you are Formula One fans, so that movie might be something for you. All right, I think we got the power supplies figured out. Oh no, we need like the second inductor. Let's check for the part. I mean, I like the inductor type, We need the inductor value to, what was the other 2.2 microhenries? So let's just look for that part. Oh shoot. It didn't copy. I hate PDF. Here we go. There we go. That's what we are talking about. Okay, that's... Oh! It's only 2.4 amps. Interesting. Fixed. Okay, yeah, I don't care. I take it. Wait, what is this? Search? Okay, here we go. No search. Let's add it. Web. And LTSC. Okay, here we go. Yeah, but if I populate like 5 boards, I can also on JLC, I can just stock up the I would use JLC parts to get plenty of them, like for $3, like you can get, I mean, I can get for 100 for $2.43, and then just use them up. So with JC parts, that's no problem whatsoever. It's the same data sheet. Footprint was again 1080, 10.8. Okay, footprint. Okay, that's saved. Now let's go to the PCB and import it. Our first test. Okay, everything is updated. Woohoo! Nice. Look at the inductors. They're not very tiny. They only look that tiny. 5 or 6 out of 10. Yeah, I would also give it maybe a 6 out of 10. It's enjoyable popcorn movie. I've got the power. Doom, doom. All the caps. Hey Casper, I can't hear you. Unfortunately, somehow this YouTube chat doesn't work. I don't know. Stupid. Maybe it was a message or something that killed it. I need to flush. Serial, what? USB interface. Foo. No, the RP uses, you can use whatever, and it uses file storage, like a mass storage device for dropping the firmware. And we have a USB hub, so when we press the button, where are the buttons, by the way? Here are the buttons. When we press the button, there will be 4 drives that will appear on this version. I mean, at some point we will make the 15 core version. Dobry wieczór. Pioga, hello. Oh, recently I wanted to tell you about this Polish influencer that I like on TikTok. But where is he? I really need to share. He's so funny. If you speak Polish, I can only recommend. Foo. I can't see my subs. Maybe I will find his. Here. Hubert Zupak. Hubert Zupak. Very funny. So enjoyable. The editing is spot on. Anyone knows Hubert Zupak? It seems. Oh wow, he has 500k subs. He is very influential. Look at that. Big one. Okay, can recommend. Yeah, I know. YouTube chat is broken. So I don't know why. Actually, will we debug it right now? We can check on what is the response that we get from the request here. Where's my debug output? Cray 1, PCB look the same. Cray 1, I don't remember unfortunately because where's my debug? Open. Huh? View, show sidebar, debug. Okay, let's see. Okay, no messages are arriving here. Let me check this one if we get anything. Huh? No, this is some other output here. Interpret result, we don't need that. What is happening? Filter initial chat. Something's broken. Web response, filter messages. We don't get any messages filtered for some reason. Unhandled error messages? No. Error, script, nonce. Filter item property done. Filter initial chat. Extract object and message data. data. Oh, it doesn't parse. Substring end. It doesn't find the end. Something's broken, like one message, or I will increase the size so you can debug with me. This is interesting. So we have a data object. Data end is -1. It has data end 2. What is data end 2? That's interesting. Data. Hopper is calling. Data ends 2. Substring. Chat console error. Not console error chat. Hä? Copy value. Can I copy the whole object? It looks like extract object. We are looking for the counts, and if it doesn't match, but if it contains like a backslash and curly braces, then it could also interpret closing braces or opening braces the wrong way. How do I investigate that? Stop already. Okay, payload. Headers, data. We copy that. It doesn't copy the whole file. You know what? We can change that to that, to have an emergency backup, and because I just need something. Oh no, close. Done. Okay, confirm deploy. No. You're falling asleep. It's reading back all the messages again. Okay, I'm super hexer. What is this again? Replace. Here we go. I just delete everything that doesn't belong here and then update it again. It's not placed anyways. Here we go. Huh? I think that was unpopulated. Oh wait, exclude, that was doesn't mean do not populate, doesn't mean that it's we excluded from, it has the footprint, exclude from board. Here we go. Here we go. Ha ha. Ah. (150 microns was the copper to constraints. I think who wants to go skiing? Wait. Did I miss Brian asking me to go skiing? Now, who asked for skiing? Oh, Brian, okay. YouTube, yeah. Yeah, I know. Here we go. That's a lot of. What is this? What is this? A minor amount of caps. Oh no. Oh shoot. Okay. Yeah, let's do the power supplies first, huh? Let's put them here because that might be. We have to populate both sides anyways. Yeah, I need to change the grid size to 2.5. Okay, that looks good. But why is this not centered? Yeah, this will never work. We need like all. How will that work? I have no clue how we will put a 48 lane bus here. We can even physically fit so many vias next to each other here. Okay, let's check the via. How many vias can we? Okay, let's start with. We will do a test run with GPIO. Oh wait, is this USB? Yeah, we need to rotate it like that. We need the USB to point in this direction. Then we have also, this should be GPIO 0, 1, X, via. Okay, let's do this. Via, X, via. And then we are already in trouble here. How do we do it even? What did I do? Why don't we just use a serial connection between the buses here? This will never work. Oh, clearance to board edge. Yeah, we need to change the constraint. Constraint 3. Or we need to make the board. Yeah. How would we ever be able to place anything here? Shit. Like GPIO 21, there is no way of placing that. Wait. Why? Should I make the grid custom? User grid. It needs to be 0.5, 0.35. How do I set up the user grids? Okay. Bus grid is bus grid needs to be C. So wait. So you need 100 from the center of a hole. Okay, now I need to think. There we go. Okay, we have the hole. The hole is 0.3 for cheap boards. Or we go expensive. Then we have 100 and that's 0.1. Then we have do we need clearance? What is where are the JLC rules? And I have them JLC minimum spacing on 4 layer is 2 layer, multi-layer 1.6. What does that mean? Why is it slash? They say 1.6. Fuck. 2.5 ounces, 1 ounce. Okay, that's 1 millimeter. That's alright. But what is about where are the 4 layer boards? Yeah, I think it's 1. So we need then 0.1 is the track. No, the distance spacing. Then we have the track, which is 0.1. But I guess this will be expensive if it's that size. They will come up with extra charges for everything. So we have here 0.2 plus 1.5. That's 3.5, 0. Okay, and then we need the 3.5 with track width of 0.1. Okay, and then clearance constraints is 1. But I think they will charge extra for, oh, we need to get blah blah, extra checking for those things. Boop. Let's remove it. Boop. All right. Let's try again. Bus DLC. Okay. Here. The preparation is key. Here. Okay. Let's try with there's no way. There's no way of... Huh? Oh, there is another constraint. No. What constraint? Minimum copper clearance. Let's do 2 here. I don't know which of the constraints was annoying. Okay, let me check again. Okay, that, huh? Strange. Why is this one so high up then? Huh? What is there? Now it works, okay. But this should be oh no, we have the pins. Oh fool. Yeah, there is no way around this. This is the grid. Huh? It's again like, huh? Why is... Something's off with the setup here. The constraints. Via diameter. Annular. Hey Ray. Hole to hole clearance. Yeah. .3. No, I think this is just in scale. It looks like they are big. These are pads. We could have smaller vias, but no, this doesn't work like that. There's no way we can route the bus. There's no way we can route that bus, pips. How would we be able to do that? The bus would need to go diagonally. Yeah, easy 4-layer PCB. It's a 4-layer PCB already, but how do you, like, if we have only this space to put everything on the bottom layers, everything is filled up. No, it doesn't matter how many layers, because what happens if you have that routed to the backside? You have no buried vias. Now you can't route anywhere on the other layer. So we would need like something like, let's say, let me pull that. Is this the right grid? I hope that's the right grid. It looks like it's off grid somehow. I don't know. I don't also see the grid properly here. This is not on grid. Here, this is on grid. This is also not on grid. Here, yeah, more area outside the IC probably. Here. Here. This is not right. Why is it snapping to some other shit. Should just snap to the grid. Like that. Okay, this is on grid, this is on grid. Maybe I should turn on the grid lines. Here we go. Okay, yeah, and there's no thermal vias here so far. 3.3 volts, that's alright, let's leave it there. Now, when I'm on second layer, let's say I'm here. This is where I can, yeah, that doesn't work. Let's pull it down. I can do both, but look what happens here. We can't put that. Oh wait, we can actually put this one on this grid. Somehow did I calculate it wrong? Is the grid wrong here? This is sitting on the grid. It looks like the clearance here is still more than 100 N. Why? Where is it? Where is it stored? Ah, here. Okay. I don't know why there are 5 different. But still, I calculated it wrong. There is no 100. Should be 2.5 plus 100, 3.5 plus 50. Oh no, it's 400. The grid is wrong. I shouldn't have to calculate it somewhere in Paint, rather using my head instead. It's 40. Yeah, we are missing. Okay, let's redo everything. This is what didn't age well. My preparation is everything. Okay, here's the grid. Okay, this is how we can route it. The bus. We have like alternating lines where we can pass the grid, the vias, I mean. What is going on? This is not on the grid. Uh, 48 more. It's not working out because I mean, okay, this side is quite clean, so I would rather build up like this, but just to get an understanding what we are talking about, I'm only halfway here. I would need like to fit all the pads for this row like in this quadrant here, and it's probably not working out. So here, this pad already is on the. Good night, Jordi. Yeah, I won't do for long today. We just run the test, and I will probably do it off. Oh wait, there is already a pad on this height. So what's happening now is we are running out of space for this here. Hegel swag. Thank you. Use the right address. You know I moved since you sent me the pink LEDs. Oh. Yeah, this ain't working. Are we reduce it to okay. Oh yeah, you can. I design like that so you can basically copy the wiring. You can use, if you're not familiar with KiCad, you can deselect all items and then just select vias and tracks, and then select them, copy, and then paste them. And since these are all on the same bus, they're interconnected. Why didn't paste didn't work? Wait. Copy, duplicate. I did it once like that. Copy. Huh? Oh, this is strange. Is this a new feature with this version of KiCad? Yeah, somehow I was able to do this, so I don't know. Maybe it doesn't like it right now, but anyways, how many are we able to fit? I can just test it by placing the vias here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 2 is 22. Or we could actually manage to do it because we can we? We might be able to route. No, we're not. So it's basically like 20. If we can do 32, then it's already good. Maybe 32 plus control lines or something. Damn it. I really wanted to use all the pins. This is hard. So look how nice that looks. This is how we would be able to like route everything here underneath it. If we need more, then we need to route it outside. I'm wondering. Yeah, if we can, we need also to cross over to the other side here. This will still work, but it won't work with these here. So it will work only for this layer, but this won't work anymore. But we can cross over on the other side. Oh, this will be finicky. That reminds me of the first cluster. It was also very finicky. 6 layer, maybe it is. Wow. I don't know about the precision of 6 layer PCBs. Alright, at this point I think I will stop here. Maybe I will just route the power supplies here. That's fun. And then we can stop. So where is this here? So alright, so we need all the caps that belong, all the components that belong to this one. So this is one LDO. You can just select on the oh yeah, all items. Select on the schematic and then bloop. These are the parts from the other LDO. Okay, here we go. That might actually fit in this corner here. The crystal will go on the other side, I believe. Oh. Bloop. Bottom side. Chip. Let's move it over. There are probably no caps that are that big. 10 microfarad caps for 402 are probably not available, so I might need to change the footprint there as well. JLC parts. Oh, let's do. They're quite rare. Oh, what? There is one. Can't believe there is a 10 microfarad capacitor that's... Seriously? Okay, 17 cents in 20 plus, it's quite... Yeah, it's cheap as well, okay. Is it available? Didn't know that there are caps that are this small. Stock, yeah, plenty of that. All right, I take it. So no problems whatsoever. We need 5 volts. Yeah, wait. Bye bye. Yeah, we'll just mess around, place it. That's the cap. What a tiny part. We need to dissipate some heat, but this is ground. Where is this going? Here. We don't need that. Oh, that's the 100N. So follow, thank you. Uh, 5 volts here and here. Okay. This was here. Oh yeah, these are the output caps. Here. Yeah, they are just stacked. Oh. Now I need to see who joined. Hey Rickard! Hello. You just joined when I'm getting tired already. Oh, I have some mute. Skål. What a nice small power supply. It's probably thermally not sound, but I take it. We can drag that down. Ugh. I hate premature wiring. Okay, here we go. We can also rotate that and is this 100N? Ah, damn it. That needs to go closer. So let's flip them. I want some order. Order. Yes, that's Kaiket. And here. And these are the how do I do it that it looks also nice? I mean, I can just move it around here. That looks stupid. Nope. Oh wait, I have more. There is more. Most important parts here, the resistors that are balancing everything. Where is this going? Now go for it. Making PCBs is fun. Try something simple first and then do more and more. Otherwise it might be frustrating if it's too complicated in the beginning. Don't show that. You don't know how to start. Take a look at reference designs and some like minimal circuits and then try to replicate them and you're fine. Somehow it looks like that could be messy here. I would like to have the caps like all on one position. I mean, having them not all in one position probably helps with like high frequency noise or something. Oh, that looks cool. Wait. What? Christian, what is it? A string? What string? What are you talking about? I'm not wearing a string. All right. Look at that beauty. Nicely placed. Not wired yet, but nicely placed. We can move it over here. Wait, the ground should be out. No, let's move ground here. USB too close to the border. Perfect. Not go anywhere. It doesn't show. Oh wait, here is 1 point. That's the 0 ohm resistor. That's the output. It will go at some point. Wait. Interesting. There is no rat's nest. That's VDD. Wait. What? Oh. Oh, power is not global. Okay. Thank you for mentioning that. That's stupid. No, you don't. Everything is free. No, 1. Okay. I will add these here. I thought this would be like global. Stupid. Okay, now we need also to import It's not miniature, but there is no space. Or maybe let me move it here. I hate it already. But this will be easier. Damn it, I have to copy everything again. Okay, let's keep it for now with this one here. And import it. But thank you for the hint. Now we have the rat's nest that you were looking for. Okay. All right. Do we do it mirrored? No, we can't do it mirrored. It will just look the same, but on the other side. Like that. Remove the labels here. I should disable all labels. Dip trace, oh man. This is amazing that that's still around. Which one is this? 10 micro. I used dip trace when I started and was board etching because they had like features for. Wait, where did I place that one? Oh, it was up there. Okay. Thank you for follow. That's the 100N. Oh. Where's this one going? It looks like I'm missing a resistor here. I see only one resistor. Where am I? Oh, they are not there. Yeah, that's how they get you, huh? And how is Altium compared to KiCad? How is the experience? Okay, here we go. Here, This one also missing the two. No, they're there. Huh? Oh, wait a second. Thousands of pins. Wait a second. Oh, that is hell. I can't route that. This is output side here. Oh, damn it. This would need to go like somewhere there, not here. This is not routable like it is right now. Okay, let's see. This pad. Because, wait, is this the feedback? This is the cap, this is the output. Oh no, that's just feedback. We can route this. Feedback isn't that bad. We can just route it here. Because that's not carrying any current whatsoever. Boop. Hoppa. What is this? Is this carrying any current? Nobody knows. And what's this? 100N. I don't know. Oh yeah, this one is. This needs to be 0.5. At least 0.5. Ah! What was that? Boom! I like it, Picasso. Boom. It's almost like a copper pour. Here we go. Meticulous design here. This is just designs. This is where design meets patterns. No. Here we go. Boom. Bam. Perfect routing. Okay, everything else is ground, huh? Okay. Yeah, let's do. What? 100%. What? There is like a 0.5mm connection. Let's reflow oven. Yeah, soaking phase. Soaking phase in the garage right now. Oh wait, that was collimated. Oh no. Okay. Here we go. Boom. Now it's unified. Piku 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 da da da. Nice. Okay, we have a winner. This is our design now. Boop, boop. PCB. We need some routing here, minus plus. Oops. Bloop, bloop. 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 Fertig. Oh no, 5 volts. Yeah, let's do the 5 volts here. Wait, but we don't need like a thick one. We can do plus. It's a cluster. It's a cluster of. Nah, that's new. This is a completely new project. Huh? Why didn't it? Here we go. 5 volts. Doo, 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 doo. Shit, no. We need thicker one here. 0.5 here. And let's go. Oh shoot. I mean, it dissipates some power. I take that. This one needs a little bit of power. Most probably. Then I don't mind everything right now here. Okay, let's remove that trace. And let's take a look at view the tree. Yes, that's a USB hub. Are they 2 versions? Huh? I didn't know there is a RISC-V version. I take whatever I get. What? That's news to me. Huh? Oh, you can switch them. Okay. All right. So, oh, it doesn't show the RP on top here. Interesting. All right. Yeah, so power supply done. No heat dissipation here whatsoever, but you will plug it in, press the boot button, no, the bootloader button, and 4 thumb drives will appear so far. But we can. Oh, what is this? More crystal oscillators. No, this is the stupid RP23 requires extra 1.1 volts. So this one is 3.3. No, 1.1. This is 3.3 volts. I just need to do the routing, which is terrible. I have no clue if I will be if I manage to do like a bus of 48 pins. I mean, it would be amazing to have a 32-bit bus plus like 16-bit control and address and whatever. But if I can manage to do 32 bits, that would be already amazing. Alright peeps, I'm tired. I have to get up in 8 hours. So this stream was nice. Maybe we can fade out with buying stuff on JLC. Where is my? I opened so many windows already that I can't find. Yeah. Yeah, that's basically it. I gave up because the inductor that you put there cost like 20 cents. This specific inductor costs, and you need to put it like the right way around and everything. So since I want to put more than 4 RPs on there, that will multiply. Each of those will take the inductor, so I just built a power supply that supposedly will be able to power all of them with 3 amps. And let's hope for the best. Yeah, they're milking us with that part. All right, so I will try to get stuff. Oh, look at that! Bluetooth antennas. But they need to be, I learned about antennas that they need to be balanced. What do we want? I want to measure the power. I have only a USB 2 device, but not the USB-C USB power meter. Let's go shopping. I received the shill money from finally, after 6 weeks. I received my shill money from BetterHelp. Yeah, not with you. I want to connect it to the PC and measure like that. USB-C. There is USB-C. Well, what is this? Input. Micro input. No. There's say, oh no, this is Temu's stuff. Hate it. Look at that. I have like one device here. This, I hate this stupid Temu crap. Oh, this is interesting. Did you try that? 4 amps! Wow. USB-C inputs. USB. Oh, I like that! That's cool. Can we get it cheaper? It's choice, so I can put it add it to the cart. This is awkward. I hate the shape. I mean, if you need a converter, I would take like this one as well. Yeah, I take the. Okay, we also need like a good power supply. Do we get a power delivery? PD, PSU, 100 watts. And I need something really gun. What is the... not wood gun. This looks like genuine. Fnerzy. Fnerzy. What is Fnerzy? Fnerzy. Oh, this one. Oh, okay. Oh, it has also two ins to out. That looks cool. $10. Can we get that meter here? No? Fnirzi, let me check. How did it look? Oh, I lost it already. Sort by price. Okay, here it has sort by price. Why is it so expensive here? Yeah, I don't care. I will just buy the plus one. Here, $14 for the Fnirzi here. Sale, big save. What? It's not a big save. It's more expensive. Brand day. Huh? Yeah, but this is original Fnirzi. Isn't this say Fnirzi factory store? That's like the original factory store. What? Or not? Sort by price, you will get like all the crap. Now you see here, $17. Strange. Yeah, I need to maybe. Okay, back to power supplies. Anyone that you can okay, 50 watts is also nice. $11 for, yeah, that's certainly not quick charge power deliveries. Ah, right. I might need like I have the one. Which one is it? Like the square brickish one, um, with the cable, and I would like I would like a replacement without the plug, so I can use it also in a different country. Something, yeah. I got similar to this one. Perseus. Yeah, but wait, there is an extra plug. Wait. No, I don't want like a fixed cable. I want a replaceable cable. Like, yeah, it could be like that. That's 150 watts. 100 watts. Is this a true 100 watts power supply? Euro socket. The last ones I got from Amazon. Wait a second, I will bring it. So you know what I mean, which one. That serves me quite well, except for if you try multiple power deliveries at once. Oh, so cozy in here. It's like 22 degrees C. Alright, so this is the one. Rev power. Rev power, and it has like this kind of cable, which I have like an American style and so on, so I can just replace that cable when I go to a certain country. And also I learned, like, you probably know this cable also from Amazon. Like, it has like the built-in LED. Wait, let me show you big. 100 watts USB-C. That serves me quite well for some time already. It holds up quite well for years now. So, and I want something that is as powerful as this one, but smaller, because this is not like this gun whatever thingy. It can do 65 watts. That is good enough for charging my laptop while driving it at the same time. Anchor, okay. Let's do 65 watts. But I would take 100 watts. Look at this. 100 watts Beseos. But they are all like with the cable is fixed. I do you remember when I did a review of their power bank? Beseos power bank. Actually, it was good build quality, but it was way too expensive. Mouse are 18 bucks. Feel long. Okay, I will try. Let's look for. Hey, Sion! You joined. We're on shopping spree right now. 60 watts. Yeah, from size-wise, it's quite narrow. Yeah, it's flat. That's good. Amazon. Car charger. USB. Anker was the so far from the power banks that I reviewed. Anker was the best quality so far. Then second place was Beseos, then was Oukitel, and all were like none of them broke or anything. So the brands are quite solid. Oh, there it is. Inu, that's my cable. The cable I got from 100 watts. Can't believe that. Look how small it is. Let's see the AI promotional video. How big is it? Oh, it's as wide as the plug. So for comparison, yeah, same width. It's not much narrow than that. Much more narrow. Nah, this is still big. Nah, this is big. It only looks that small, but this one is the same width A little bit, like maybe 1 millimeter. You green? Let's see, not 100 watts. 150 watts. Finbo. 1000 watts. Let's look for 1000 watts. Belkin. That looks comfy. How big is it? 65 for PC, 45. Oh, it can't do both at the same time. So that's the same issue like with this one. It will be basically the same power supply. It's also the same width. Nah. This one is smaller. But I don't like the white color. Yeah. Okay, 5. Let's measure. Let's drop the pants and measure. Where's my microchip ruler? Okay, this one is 40 by 40 millimeters. 40 by 40 and length is 7.4 centimeters. So it's small actually. Okay, 28. That's not bad. 58. Let me check. Oh wow, yeah, that's small. 28. What? That seems. Let me look for that again. Maybe Filong it has that they don't have it here. Output power 60 watts. I like it. It's as narrow as this plug here. I like that. Three amps at 20 volts. Okay, that's an option actually. They're all with built-in plug. These are smaller here. Look at that. What is this? Is this like an adapter? UK, EU. But how do you wait, is this the power? No, what is this? How do you connect it? Oh wait. Oh, on the other side you just push out the plug type. Cool. Wait, what kind of types do they have? 600, 140. Okay, I think I'm done. Equalizer. Oh, you had one of those. You're the second one. You're the second one mentioning the visit at David's. Brian was here before, and he mentioned when that I drilled the pipes. Oh man, embarrassing. Oh, look at this. I like this. Look at that. The plug is it's narrower than the plug. That means this is small. This is small. 100 watts. Power delivery 3.1. What? This is what I'm looking for. Maybe. I would love the extra cable, so it's not like pointed because that these things tend to break because I'm sloppy. Yeah, I miss him too. You green. Oh, wait a second. I like that one. That's a. Wait a second. Look at the form factor. You have USB-C 1 and 2 and then okay. Let's see if it can deliver both at the same time. Because I would love to have my PC connected while charging my phone at the same time in the train. Usually in the train you have only one plug and you can do only one thing at the same time. Yeah, I know. Ugreen is great. They made also power banks, I believe. Pixar. Do you know, Sion, do you know by any chance if um, you can use both at the same time if the laptop charges like takes 60 watts? Or is it like turning off one of the ports? If you, I don't know, my this power supply only can do only one power delivery at the same time. Okay, they say this is bad translation. Okay, yeah, that's all right. As long it doesn't turn off. I mean, I can always let me put it that in my just for reference. And I think the shopping spree, the most thing that I'm looking for are those values, but I don't know. Wait, oh 04 or 2 inductors, they probably not. Okay, oh 06, oh 03, there are not many values possible. Let me check. Nano henries, 2.7 microhenries. That's for the 08, 05. Maybe I should get. Yeah, the nano henries don't do any 8. 06, 03 have also. They have always some kind of sale. Okay, there are some micro Henry values as well, but I don't know what the resistance is. Probably quite high. There are more values in the 1206, 0805. Quite some cool micro tariff for US. Can you stack inductors on top of each other? You probably are. The resistance will be lower, but oh, they might affect each other. Oh, okay. Peeps, I will go to bed. We will see if I buy a charger and what kind of. And I will try to root the RP project and order it this week, and next week we can expect the other project to arrive. It's already in Bahrain. Let me check that. Where is my... Here. Oh, it will... Yeah, no, I will dox myself if I show... Extend this tracking. Arrived at EU distribution center. Okay, here. Arrived at distribution. Sion, you missed the treat. I will show you the PCB, but okay, maybe let me load the KiCad. Here, this is not the one. Here. This will arrive by next week, and we will be able to... Yeah, look at that. They didn't complain. JLC didn't complain. About this board. Okay. You're educated to guess, Sion. What is it doing? You need to ask Sonic. Yeah, we have a from last stream we have a clip. Pew 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 pew. Okay, so this USB-C, then we have the CH570, and this is RCA video signal. And both are just PCB connectors. There is no connector placed here, no connector here. It's just, this is going inside of the cable, 0.8 millimeters, and this is like this. This will go on the end of the RCA. Supposedly. JLC didn't complain that I... I don't know if USB to RCA will work, but RCA will work for sure. So video signal generation works with the... It's a challenge. It's a 13-cent risk V with USB stack. If we can make CDC work with that, we could send text and display text or whatever, because we can. look how I didn't use castellations or whatever. JC didn't complain. I used long holes and then routed them here. If if they if they it only needs to be like a part of it. It only needs like to be somewhere connecting. Like, okay, we will see. I ordered once, then it was like some fringing at the edges of that, but we will see what I will get. This is interesting. Especially here there will be some strange behavior. But I think did I do the route? I think I did the routing. Wait, let me show the edge cuts. Okay. Look at the edge cuts are going here, so they are in mid-air, so the edge cut tool won't touch this surface. It will go to here and then cut here. So you know, they will curse me because they will break their tools if they manufacture it, because these tabs will fly around everywhere. Like these, I mean, it could be connected to somewhere, but I believe these thin parts here will fly around in their tool wide. Like I think let me measure. It's 11 millimeters. Yeah. 11, and lengthwise it's 19 millimeters. So it will fit in one of these connectors here. Like this RCA connectors. I hope it will look like one of these in the end. So this is what I'm looking for, peeps. This is we can check it out next week, and we have a project. Yeah. Um, I think they complain if it's beneath 1 centimeter. We are just above 1 centimeter. Anything below 10 millimeters, they start complaining. But they charged me something extra. Let me check. There is like a surface finish, but surface finish, you never know exactly what they mean with the extra pricing that they do. Let me check. Okay, just need to take care that I. Okay, this is uh, no. Blah blah blah. I don't see anything here. Anyways, thank you for watching, peeps. I see you next time. Probably next week, because Friday I will finish the other PCB and order it, so I won't have much time. And tomorrow I'm visiting my dad. Bye bye. I paid total, I think, $17 with like $5 coupon. $15 or something with including shipping was the total with customs and everything. I ordered 10 boards. That's only PCB, no stencil. Bye bye everyone. Good night.